You know that scene, right? You're in a busy cafe, you look around, and there are dozens of people on laptops, phones, tablets, all hammering away on the same Wi Fi network. How does that not just collapse into total chaos? And for that matter, how does your phone stay connected to Wi Fi all day without the battery just dying in an hour? Well, I'll tell you, it's not magic. It's actually a set of really brilliant engineering principles that make our whole wireless world go round. So that's the big mystery we're going to unravel today. How do all those devices share one signal without creating a total mess? We're going to solve it by looking at three key things: the actual hardware that makes it all possible, the really clever rules of the air that prevent digital traffic jams, and finally, the secret tricks your devices use to sip power instead of guzzling it. All right, let's get right into it. First things first, the hardware. Every single Wi-Fi network, or what's technically called a wireless local area network, a WLAN, it's all built on two fundamental pieces of equipment. Okay, so inside your laptop, your phone, pretty much any device that gets online, you're going to find one of these, a wireless network interface card, or WNIC for short. The easiest way to think about it is as your device's personal Wi-Fi translator. It's the thing that takes all the digital ones and zeros from your device and turns them into radio waves that can be beamed out through an antenna. It's literally what lets your gears speak the language of Wi-Fi. And the other key player in this whole operation is the access point, or AP. You probably just call it your Wi-Fi router, and honestly, a great way to think of it is as the air traffic controller for the entire network. It's the central hub that manages all these wireless conversations, and, this is crucial, it's the bridge between all your wireless gadgets and the wired internet. And you can see that role perfectly right here. The access point is sitting right in the middle, playing director for all the traffic. It's grabbing the wireless signals from those two laptops and connecting them over to the wired network, which is where that PC and the file server are living. Seriously, without that AP, those laptops would just be stuck on their own little digital island. So, now we've met our key players. You've got the WNIC inside your device and the central access point. But it turns out you can set them up in two totally different ways. These two methods are called infrastructure mode and ad hoc mode. Now, infrastructure mode is the one we're all super familiar with. It's the one that relies on that central controller, the AP. But ad hoc mode is different. It's a direct device-to-device link with no middleman at all. So this is infrastructure mode. This is the standard setup for basically every home, office, and coffee shop you've ever been in. Every single device, every laptop, every phone talks through that access point. It's organized, it's managed, and it's what lets a whole bunch of devices share that one connection out to the rest of the internet. And then you have this, ad hoc mode. Notice what's missing? Yep, no central access point. In this setup, the laptops are talking directly to each other, peer-to-peer. This is super handy for setting up a quick, temporary network, like if you wanted to zap a huge file between two computers and didn't have a router handy. Okay, so we've got our hardware, and we know the two main ways it can be connected. But this brings us right to the biggest challenge in all of wireless networking. When you've got all these devices sharing the exact same slice of air, how on earth do you stop them all from talking at once and creating absolute chaos? Well, the big enemy here is something called a collision, and it's pretty much exactly what it sounds like. If two or three or more devices try to broadcast on the same frequency at the exact same moment, well, their signals crash right into each other. And the results? Both messages just become garbled, unreadable static. Total noise. Now, here's the really brilliant insight. On a wired network, you can kind of detect collisions and fix them. But in the invisible world of radio waves, that's way, way harder. So the whole philosophy behind Wi-Fi isn't about recovering from collisions, it's about avoiding them from the get-go. The entire system is designed to act like a very, very polite group conversation. And this polite conversation is managed by a protocol with a mouthful of a name, CSMA-CA. It stands for Carrier Sense Multiple Access with Collision Avoidance. But the process is actually simple and brilliant. First, a device just listens. Is anyone else talking? That's the carrier sense part. If it's busy, it backs off for a random amount of time. That's the collision avoidance. And then, once it sends its message, it waits for a quick, I got it, acknowledgement, just to be sure. The real secret sauce here is that random waiting time. Let's watch it happen. So device A just finished talking. Now B, C, and D all have something to say. But instead of a mad dash where they'd all collide, they each pick a random back-off interval. As you can see, device D just happened to pick the shortest wait time, so he gets to go next. That simple little bit of randomness is what keeps the whole network from falling apart.
But what if you have something really big to send, like a huge file, and you absolutely cannot afford to be interrupted? Well, for moments like that, the system has an extra layer of politeness built right in.
It's called Request to Send / Clear to Send, or RTS / CTS. Here's how it works. A device sends a tiny little Request to Send packet to the access point. The AP then broadcasts a Clear to Send packet to every other device on the network. This basically tells them all, hey everyone, shut up for a minute. The line is reserved. It's kind of like booking a conference room for a really important meeting. Okay, so we've solved the chaos problem. We've got our polite conversation rules. Now for that final piece of the puzzle. How do our phones and laptops stay connected all day without their batteries just giving up? The secret isn't just about having a sleep mode. It's about having a synchronized sleep mode. For power saving to actually work, the mobile device and the access point have to be perfectly in sync. The goal is for your device to shut down its power-hungry radio, but do it in a way that guarantees it won't miss any important incoming data. It all happens in a little 4-step handshake. Your phone tells the AP, hey, I'm going to sleep for a bit. The AP says, okay, got it, and starts collecting, or buffering, any data that's meant for your phone. It keeps track of this on a special list called a traffic indication map. Then your phone wakes up for just a millisecond, checks that map, and if it sees a message waiting, it wakes up all the way to receive it. If not, back to sleep it goes. You can think of this traffic indication map, or TIM, as a public notice board that the AP maintains. So in this picture, both device A and device C are asleep. The TIM has a big yes next to device A, which is the AP's way of saying, hey, A, wake up, I've got something for you. But it says no for device C. So when C wakes up for that tiny millisecond check, it sees the no and can instantly go back to sleep, saving all that precious battery life. And there you have it. The Wi-Fi mystery is solved. It's not magic at all, but a really sophisticated system built on these core ideas. You've got the essential hardware of the WNIC and the AP. You have the flexibility of infrastructure and ad hoc modes. You've got the elegant collision avoidance rules of CSMA/CA, making sure everyone plays nice. And finally, you have those smart, synchronized sleep modes that keep our batteries going all day. It's a truly elegant system, one we rely on every single day without even thinking about it. But it does leave us with one last big thought. These rules were designed for the world of laptops and phones. So what happens when the Internet of Things adds billions more devices to this global conversation? Are these polite rules going to be enough to maintain order? If you want to keep exploring the technology that's shaping our world, make sure you subscribe. Thanks for joining me.